Hello students, this is our course that here we're dealing with the system Verilog. Main motto behind this particular set of tutorials is to introduce from basic to the advanced level of the system Verilog. All the aspects of system Verilog here I try to cover. But thing that which I want to tell you now that any of the PPT here that I'm going to utilize is not prepared by me. That is standard set of PPTs either by the synopsis or either by the mentor graphics. The books that I'm following for this particular course I tell you later on. One thing in advance I want to make sure that before starting this tutorial you should at least have some basic knowledge of Verilog, and but if you are not aware about the Verilog and you are only similar, you are having a hands-on experience with VHDL, for that particular viewers I will also start another set of web tutorials side by side for the Verilog. But to capture this particular information of system Verilog, I request till the time I will upload that particular videos on Verilog, you go through Verilog by J. Bhaskar or by Kleti books. Now let us start with the system Verilog. Actually, system Verilog in itself is nothing a new language, but it is a new subset that has been added in the Verilog. Some new functionalities has been added into the Verilog. Based upon that, it has given a name of System Verilog. Main motto behind the introduction of System Verilog for the SOC verification, system on a chip verification. Simple test bench that has been written in Verilog that are also capable of doing the verification. But to have portable test bench, you need a system Verilog. Let us start to understand. Here, the two things I want to introduce. For system Verilog, you are having a three tools: PastaSims by Mentor Graphics, VCS by Synopsys, and ICSim by Cadence. And in this particular tutorial, I am going to utilize two tools, that is a PastaSim and VCS. Mostly programs that try to try to make and run, that will be on a PastaSim, but also try to cover VCS. PastaSim is the advanced version of your model sim. Model sim you can download and run on your system by downloading from the Mentor Graphics website for the student version. But PastaSim you have to purchase. These are the some specific steps that we utilize further, that will be aware to you very soon. Now this will be the window of your PastaSim. That is very much similar to your model sim, nothing new. Like this is your workplace, and this is your MD pan and toolbar, and this is your command area. Similarly, you will have a waveform window, object pen window, from here you can add all the objects that you want to observe in the waveform, in this waveform section. Later on, as we carry on our tutorials, this will be clear to you time by time. What is the need of verification? Data types, new array and the structures that has been added, then followed by packages and tasks, functions, fork join, mailbox, semaphores, assertions, and cover. Now let us see how a test bench in system Verilog includes various components, how they work together. This is a design and a test, followed by some drivers, some monitor sections, some scoreboard. This is some layered form of a test bench. This is a DUT design under test that will get inputs, random inputs that are created by a test and handled by the driver and supplied to this DUT. And assertions, what is the need of assertion? What is scoreboard, monitor, checker, that we cover step by step. But the thing you have to keep in mind, writing a test bench in system Verilog includes writing a driver, transactions, a test program, assertions, monitor, checker, and a scoreboard. Each and every unit has its own functionality. What is a test bench and how to connect a test bench to your design under test? How should you connect your DUT? Let us suppose someone has given to you a DUT, design under test, name as arb.sv, having some inputs and some outputs. So for that DUT, very much first step is to develop an interface. Now what is the interface? Here, instead of directly dealing with the IOs of your DUT, the verification engineer will deal with your interface module that we will cover later. Interface module include two sections, mode port and a clocking block. Mode port will tell to enter the interface that which variable is acting as an input to the DUT and which variable is acting as an output to the DUT, and all the signals that are sync with the clock that will be handled separately in the clocking block. Then create a test bench program. Normally in Verilog test bench we have a top module, but here you have in system Verilog you have a separate program block followed by a top module. Then you have to link them and compile and run. This figure shows that this is your top module followed by this arb.svdut followed by test bench, and this thing some here you will have an interface followed by a clocking block. Now let us suppose you are having two module memory having some input and outputs and inouts. Similarly you are having some module CPU, some input, some in-out, some output. Now you have to link both of them in a top module top. What is the logic that we will cover later on. Now look here what is happening. You instantiate memory module MEM with M1 and you are going to write each and every signal one by using position association. Then you have to go with the CPU module. You have instantiated CPU with the name C1. Then again each and every signal one by one using position association. Let us suppose somehow here you are having a 2 4 6 8 signals. That is much easier to handle. If you are on a SoC system on a chip, you have number of inputs and number of outputs and their combinations, permutation combinations. That is a very complex to handle, but interface made our job very much easy. Now see, you will declare a module interface and its name simple underscore bus. Now simple underscore bus is the interface to mem and CPU. Here mem and CPU both are connected, each and every signal one by one. Now it is the responsibility of the interface to map both of them. So instead of writing reg clock and everything again and again for the memory, and if you look, you are having a reg here, having a clock and a start. You are having a reg here because this is the input to the memory, and that will definitely coming output of the CPU. Input of reg, then clock, then start. Data will be output from here. Reg, start, data, sorry, mode and address. Now what will happen? An interface will encapsulate all that signal at one place. Logic is a keyword that is a new thing to you, no? To you, we will cover later on in the data type section. You are having a now. See, you are not aware about, you are not, and you are not going to bothering about one very important thing in here, that which one is the input and which one is the output. Like here, you have to take care that if this is the input here, that will be definitely output from the CPU. Okay, but here nothing is like that. Okay, now you are having a logic request and GNT, short form of a grant, then logic of 8-bit ADDR, wire of 8-bit data, logic of mode of 2-bit, logic start ready. Done. And interface. Now see how the things become very much simple. Module mem, look, module mem, you have defined everything here. Now here you will just write the name of interface and you will instantiate that as a SP, and you left with the clock that is not defined here, and we are not discussing here the clocking block. Okay, we are discussing only interface. Input bit clock. Now see, module CPU, each and every signal again that has been defined in mem. Now instead of writing that again, we will just write the name of interface and instantiate with a name that should be same as that of a mem. Okay, and module. Now see how the things become very much simple while you're writing a top module to bind mem with CPU. You will write logic clock and you will toggle this clock for every 10 time minutes #10. Now interface name and the name with which you instantiated you will call here. Now here, name of module mem. Now you will write only SP. Similarly CPU C1 SP. Not like this in a normal module, the approach that you were following previously. So with the help of interface, the things become much easier. Something become bit complex that we will discuss later on. This is just a bit of introduction to the interface means, what is new in the system Verilog. Now question is that how will you assess something from the interface, and like by keeping our previous example, module CPU simple bus SB you have instantiated and input bit clock. Logic ADDR underscore reg, always at a passage of a clock you want to give the value of address reg to the address, to which address, interface dot address. Okay, by utilizing it is just similar like when you have declared some object in Java, and with that, and while creating object of in a main class of a Java, you create a handle to that object, and with that handle you can access the another variables of that class. The similar way you are following this. Okay, we will cover it. It will be much clear to you when we cover this in a chapter of interface. Now in a previous slide we have mentioned that there is something named as a mode port that is linked with your interface. Now if you remember, here I mentioned that there is nothing to mention which one is the input and which one is the output. If you are working in a Quasta sim, the simulator is too smart, it will manage by by automatically input and output, but that is not a good approach, because as Verilog is not a strongly typed language as that of VHDL. VHDL is a strongly typed language, but Verilog is a weakly typed language. Okay, but it is a good approach to tell which one is the input and which one is the output. What is a method to define which one is the input and which one is the output? You will create a two mode ports now: mode port slave, mode port master. It is just like creating another module with some name and defining inputs and outputs, means defining the direction. Now, while instantiating this interface in module CPU, previously you're doing only something like you're doing interface name followed by the name with which you want to access this. Similarly, now here the bit is changing. Simple in underscore bus is the name of your interface followed by a master. Now what is a master? Master is a mode port. From this mode port, this CPU will get the directions of EDDR, GNT, all that. Similarly, bus will take the slave mode port. Now the direction will be understood to CPU and mem. Now another thing, that is a clocking block. Clocking block is another section of interface, like mod port is a one section. Now clocking block is another section. Now let us suppose this is my DUT having input reset request as an input. When this DUT have a request, it will grant some information to the accessing block, and it on every edge of a clock. If reset is a high, whole DUT will be reset. Okay. Now I want to write an interface to this DUT. So interface is a keyword, like module is a keyword. For interface, you are not going to create a module, you will create an interface as an interface. Okay, we will cover all this in our lab sessions. Interface name followed by this. One more thing I want to add, this PPT, these all PPTs I will upload on my blog. You can download that PPTs from my blog. Address of that blog will be given at the end of this tutorial. One thing you have to taken care while writing an interface. Now this is an interface having a no clocking block, so there is a nothing written in the form of brackets. But one thing you have to taken care, keep in mind that interface can have only one input, and more than one input it can have. But actually, what is the main input to the interface from the external, from that is a clock, input bit clock. Like this. CPU mode, this is your interface having a clock as an input. Okay, now clocking block is, syntax is clocking. Name could be any. Here we have given a CB at a passage of a clock. Now grant and the request both are synced with the clock, so that will be written here: input grant and output request. Okay, so these two are now sync with the pause edge of every clock cycle. A mode port, input clock. See one thing, in this there is no input clock. Now you have to write input clock this mode port. Okay, because all the signals are sync with, not all the signal, that has been mentioned in CB, that is grant and request. Reset has nothing to do with the clock. Mode for this mode for DUT will have an input as a clock, input as a request, and a reset, and output as a grant. Now in test bench you have only a clocking block. You have nothing to write like this, okay, because that two signal of the test bench is synchronized with this clock. Whenever there's a passage of a clock, test bench will send some data for grant and accept back something from request. Okay, output reset is asynchronous. An interface can have multiple clocking blocks, okay, because some can work on a passage, one can work on a neck edge, some can work on both the edges, some signals. So based upon if some signal are working on a passage, some signal are there with the neck edge, and some signals are on both the edges, you will have a separate 3 clocking blocks. Before moving in a depth for the system Verilog, let us start with the data types. System Verilog has introduced some new data types. In Verilog we are confused with sometime where to use logic, where to use wire and where to use reg. That solution is provided with the help of a new data type, that is a logic. In system Verilog, our reg type is modified in the form of logic. Okay, an old reg type has been extended so it can be driven by single drivers like a wire. Okay, you will have a 4 state main 0 1 x and z, x for unknown and z for high impedance. We also have a bit, integer, int, byte, shortend and longend. The integer, other are the 2 state types. Bit afford only 0 and 1. Int can afford only 0 and 1. Similarly, byte, shortend and longend. Okay, one thing you have to remember that 2 state variable gives a better performance because they have not to propagate x and z, so they will not do any calculation for x and z, they will do only calculation for 0 and 1. That's why they have to handle only 2 types values, 0 and 1. That's why the 2 state variable form better. Second advantage is for the 2 stated it that they reduce memory usage. System Verilog also support user defined data type. Type def bit. Type def is a keyword. Bit is a 2 state data type, 31 down to 0. Uint is any user defined name. Okay. You can also create a structure with a multiple variable. Type def struct, a user defined new data type, that is instruction, that is a collection of bit 7 down to 0 opcode and a bit 33 down to 0 adder. This is called a name structure. Similarly, you can have a union. So that's all for this tutorial. In the next tutorial we will cover fixed array and dynamic array.